Let's graph two more functions. We'll look at y is equal to negative 2 sine theta and y is equal to 3 cosine of theta. Recall that both are in the form y is equal to a sine theta, y is equal to a cosine theta. What's the value of a in each case? For y is equal to 3 cos theta, a has a value of 3. For y is equal to negative 2 sine theta, a has a value of negative 2. Remember that the amplitude, though, is the absolute value of a. So the amplitude for y is equal to negative 2 sine theta, the amplitude, absolute value of a, is 2. And the amplitude for y is equal to 3 cos theta is 3. Remember that the amplitude is the distance traveled from the midline to the maximum or the midline to the minimum point. What exactly are we being asked to graph here? Well, we'll have theta running from negative 2 pi to positive 2 pi. So we'll want to write those angles on the graph. We also have those same values listed in our table. So let's start with the table, having a look at the values of the angles. We've already looked at 0 to 2 pi. From 0 to pi, halfway through, we're at pi over 2. And if we break up pi to 2 pi, break it up in half, halfway through is 3 pi over 2. Half the distance between 0 and pi over 2 is pi over 4. Now remember, maybe the easiest way for you here is to count in pi over 4 from 0 to 2 pi. So 0 plus pi over 4 is pi over 4. Pi over 4 plus another pi over 4 is pi over 2. And then we have 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. The same thing happens in the negative direction. We'll again count by quarters. Negative pi over 4, negative pi over 2, negative 3 pi over 4, negative 3 quarters. Negative 4 pi over 4 is negative pi. Negative 5 pi over 4. Negative 6 pi over 4 is negative 3 pi over 2. Negative 7 pi over 4. And negative 8 pi over 4 brings us to negative pi. Our next job is to evaluate 2 times the sine of theta for each value of theta. There are 2 ways that you can do this. As we're getting started, let's reach for our calculators. Remembering that the angles are in radians, calculate 2 times the sine of each angle in radians and record the answer. Let's graph that. We're going to need some tick marks on our graph, so we'll have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, or 2 pi. So I'll just label these. All right. Let's start at 0, 0 and graph this on the positive x-axis first, and then we'll move on to the negative. So we start at 0. We move up to 0.7 and then up to 2. Up to 1.4 and then up to 2, down to 1.4 and down to 0. Keep going down towards the minimum. So now we're at negative 1.4, negative 2, negative 1.4 en route to 0 again. And we should recognize our sine wave here. Of course, this continues as I move to the left. As our calculations show, we're now headed from 0, 0 down to negative 1.4. And then finally, when we get to negative pi over 2, we hit our minimum again at negative 2. Back up to negative 1.4, back through 0 when we're once again halfway through one period of this function. Heading up to positive 1.4 on our way to the maximum when we're 3/4 of the way through the period, 3/4 of the way through the function, back down to 1.4, and finally we hit 0. You'll see that the shape is exactly the same in this second period that we've now drawn as it was in the first one. The only difference between y is equal to sine theta and y is equal to 2 sine theta is the amplitude. The period is the same, but instead of reaching a maximum of 1 and a minimum of -1, we reach a maximum of 2 and a minimum of -2. The amplitude for this function is 2, but it's otherwise the same. Based on that, how do you think y is equal to -3 cos theta will differ from y is equal to cos theta? So we previously graphed y is equal to 1 times the cosine of theta, and now we're going to graph y is equal to -3 times the cosine of theta. There are two differences here. One is that a is a larger number, or the amplitude is a larger number. Amplitude will be 3. Just realized I have a difference between what I wrote up in the header of the question and what's actually written in the chart. So know that we've been graphing what's in the chart rather than what's in the question. My apologies for that. So back to y is equal to -3 cos theta, where the amplitude is 3. So a is equal to -3, but since the amplitude is the absolute value of a, it's equal to 3. So for this graph, the maximum we'll hit is 3 and the minimum we'll hit is -3. How does the negative change it? Well, that's going to flip the graph. Every point that was positive will become negative and vice versa. Let's see how that affects our table of values. Let's start again at an angle of 0. Normally, cosine is at its maximum when we start. The cosine of 0 is 1. But now we need to take the cosine of 0, or 1, and multiply it by -3. So we'll start at -3. Of course, if we start at -3, we know we'll end at -3. How does cosine work? Normally, it starts at its maximum, goes to its minimum, and ends at its maximum. Ours is upside down, starting at the minimum, but we're at the maximum halfway through. So we'll find that this has a value of 3. Check it with your calculator. What is -3 times the cosine of theta? You should get a value of 3. In between, at the quarters, that's where we'll cross a 0. 0 times anything is still 0, so those are still there. And then finally, try these ones. We get -2.1, 2.1, 2.1, and -2.1. Try filling in the whole table of values from 0 to -2 pi. Now let's graph that. Start on the positive x-axis, but starting at the origin where x is equal to 0. The value of y is -3. By the time we get to 2 pi, we'll also be at -3, and we saw that in the middle, where the angle is equal to pi, we're at +3. Pi over 4, we're at -2.1, and at pi over 2, we cross the x-axis. At 3 pi over 4, we're at 2.1. 5 pi over 4, back down to 2.1 from our maximum at pi. Cross 0 at 3 pi over 2, hit -2.1 at 7 pi over 4, and as expected, we're back at -3, we're at an angle of 2 pi. So let's graph one more period from 0 to -2 pi. Okay, watch that your points are not too pointy. This should be a smooth curve. We're not drawing zigzags at any point. How do we know we're not drawing zigzags? That's why we've put in some additional points between the critical ones, the minimum, the zeros, and the maximum. We'll get much more comfortable playing with these graphs in the next module. But for now, we're going to be using a table of values and then plotting those points on the graph. But you can start to see that the value of a makes the graph taller or shorter and can also flip it upside down. So the value of a stretches the graph or shrinks the graph in the vertical direction.